Okay, so we have two inequality questions here, and as a reminder, an inequality in many ways is just the opposite of an equality. There are two types of symbols that you'll usually see with inequality. The first type is either less than or greater than in some order, or or less than or equal to or greater than or equal to in some order. We don't know what these symbols exactly mean because we don't know which way to read it, but we do know that these first two appear means that one number is either bigger or smaller than another. So for example, 1 is smaller than 2. And of course, this symbol down here could mean something like you have a mystery number and it's less than or it's equal to 2. So anything that's less than or equal to 2, and that could mean, of course, right, 1 or 2 or 0 or -1, and you can think of these in any order, just any number that's less than or equal to 2. And here we're graphing that, right? They're saying what inequality is represented by the graph below. So this graph, this line represents all the numbers, this bold line right here, that we could use in this inequality. And this open circles refer to these symbols up here, and closed circles refer to these symbols, right? The idea being that with a closed circle, wherever you put the dot, your answer, the graph of the numbers that could satisfy this equation, is part of, right, where you put the dot. It's included, so it's colored in. So here I could put a dot at 2 because 2 is a number that is equal to 2. But here if I said, well, let's use this, x is less than 2, for example, the dot that I put on the graph, that location, I would put it at the number 2. So let's try that out. Here's the number 2. I would put it at that number, but this number is not included in the answer, and x is less than it. And we're graphing x, so the arrow goes this way, right? But again, with the other dot, 2 would be included in that answer, right? Because it's one of the possible values of x, but still it's 2 and everything less than it. And that relates to this inequality, whereas the top one, right, relates to this inequality. So here, what does this represent? Well, I mean, it's all these numbers that are bigger than, -1, but not including -1. So we use an open circle. And that's what this is. You can just see all these numbers are larger than -1. And that dot tells me where to start. And that's it. In the second example here, it's two inequalities kind of put into one. It says -2, right, is less than or equal to x, right, and x is less than 4. Now, you might want to read this from the perspective of x, because that's what we're trying to graph. So where is x? Well, x is a number that's bigger than or equal to -2. So let's start by graphing that. We really only need to graph these endpoints here. And -2. So x is something that could be bigger than that, right? And it has to be both things at once, so it goes this way, and it has to be less than 4. So let's say 0 is over here and 4 is about there. And it's less than 4, not equal to 4, so it has an open dot there. And these are the values of x. Well, you know, one thing you're wondering is, well, if x is less than 4, couldn't I pick a point over here like -3? And since x is bigger than -2, couldn't I include a point like 5 because that's bigger than -2? The answer is no, because x has to be bigger than or equal to -2 and at the same time less than 4. So whatever value of x you pick, it has to be both bigger than -2 and less than 4. And that's, you know, that's just a fun way to put constraints on a problem like this. And just watch out to make sure the problem like this, that these dots match the symbols here. That's one thing to try to find a way of remembering. All right, thanks.